Shane. I'm the field CTO of Monte Carlo. Monte Carlo is a data and AI observability company. Prior to that, I led the data teams at the New York Times for about a decade. And I'm originally from Australia, Sydney, Australia. I've been in New York for about 15 years. Maybe a little ironic that I'm talking about day 2 problems on day 1 here, but hopefully that'll be okay. And the click is not working. Okay, so I'm going to try to touch on a couple of areas. One is how we build AI at Monte Carlo. An observability company is essentially helping you to detect, resolve, and prevent data issues at scale. And so AI is becoming a critical part of our workflow in Monte Carlo. But I'm also going to talk about what I've been doing in my most recent role, which is kind of deep research and product strategy with dozens of Monte Carlo customers and non-customers to understand how they're building with AI and how they need to ensure the reliability and quality of those applications. And so I'll start with what I've called the illusion of done, and then move on to just some quick lessons from building impactful AI. And then third, just tackle a little bit about operationalizing reliability and trust. Okay, let me click through here. Okay, so we recently did a survey with Wakefield Research just as a starting point. Probably not surprising to anyone in this room, but 100% of data professionals feel pressure to build generative AI products. 91% have built or are in the process of deploying generative AI products. And then 90% there on the end don't think their leadership has realistic expectations. And typically, what data teams that I've spoken to over dozens and dozens of teams are launching these AI products to whatever scale they can, and then sort of thinking about what's next. And what's next is pretty complicated. And I think we heard it earlier in the keynote from Chip, but the paradigm has really shifted. I spoke last week to a data engineer, a machine learning engineer, who essentially said AI is making deploying apps much easier in their company, but makes observing them much harder. And part of the reason is they have a raft of new inputs to these models, unstructured data inputs, in addition to the structured data. The output of the models is probabilistic rather than deterministic, and they're finding that small issues, very small changes, which I'll talk about a few that have come up in conversations I've had, can have cascading issues or failures down the line. And so while these generative AI apps have huge visibility both within the organization and sometimes outside, they don't really have much in place in terms of ensuring the reliability of them. And so I'll just go into maybe a little bit more about why generative AI is so different. This is just an example of the emerging LLM stack. The last talk actually went into more detail around these sort of RAG-based models that can bring in various contextual data. You have the RAG components, the embedding model, and potentially a vector database, and then potentially, versions of prompt training. The reality is, and we also heard this in the keynote today, that the latest and greatest models from Google and Anthropic and others are available to anyone, and so they're a commodity. And what makes these models different in application is your data, your proprietary data at your company. And what data people tend to know, and I think what software engineers are finding out, is that data environment is complicated, it's messy. That first box there, which says Databricks on this and Airflow, is full of systems and tools unto itself, complicated data pipelines that the data team are attempting to manage and make available. And then an astounding 68% of leaders in this study that we did basically said they don't think their data is AI ready. AI ready, I think this is kind of a fairly ambiguous and weird kind of buzzy term that people are using. And often, you're finding data leaders sort of trying to prepare their data for inevitable AI. But I think from speaking to various teams across industries and also from building internally, what I believe is the way to make your data AI ready is to actually build something that forces you to reckon with that data readiness, rather than sort of sit there and wait for the inevitable. So I'll start just in terms of these lessons with an example from Monte Carlo. As I mentioned, we handle observability for data and AI teams. And so we actually have two agents. We have a monitoring agent that helps users to create essentially monitors to cover their data pipelines and understand what they should be monitoring at scale. And we also have this troubleshooting agent that's very recently released, or is actually being released in April. So let me talk a little bit about this. The problem here is that when data engineers find an incident, when something like Monte Carlo or another observability tool finds an incident in your data, it's very complex to actually find the root cause of that. And so data engineers are often navigating an increasingly complex set of systems, data pipelines, and owners across the business. And every second can mean, both wasted time for the business, but also a cost to the business and sometimes reputation. And so this is really a first-order problem for data teams, has been reducing the downtime and the time to resolve these incidents. And so what the troubleshooting agent does is it investigates, verifies, and explains the root cause of data and AI issues. And then it also provides recommended next steps to the team to resolve them. And how it does that, you essentially have various hierarchies here of agents operating. The one at the top essentially looks at the sort of nature of the incident and kicks off a bunch of topic level agents that are going to explore ETL failures, failures in the data sources upstream, failures in Airflow DAGs. And so these topic agents will then actually deploy their own task agents for every version of that that's possibly occurring. So you have this kind of parallelized approach to going and exploring every hypothesis for what could be causing this data incident. That is brought back and summarized by this sort of main agent. And the idea over here is that you actually reduce that time to resolve incidents by about 80% by taking this approach. So you think of it as replicating the job that a data engineer might do in terms of exploring potential causes of incidents, creating hypotheses, and then diagnosing them. So we built this in AWS Bedrock with Claude 3.5 Sonnet. As I mentioned, there's this kind of hierarchical agent structure, but it really provides us with the ability to add and remove agents from this framework pretty quickly to evolve the operating of this. What else? I just want to share I mentioned I've been doing a bunch of research with customers in media, streaming companies, automotive, finance, healthcare, education, gaming. And I think, one thing that we've heard a bit about chatbots at the conference so far, well, chatbots tend to be the most common use case people are going for. They're also incredibly challenging often to get into production. And kudos to your team for getting that work into production. In my conversations, sometimes I'm finding the sort of easier apps to get into production are things like structuring unstructured data with LLMs, or transforming internal human-driven decision processes into human-reviewed processes, or sometimes even looking at things like summarization or other sort of tasks that are incredibly human-centric in the organization and repeatable. One thing I found is that human review across these dozens of teams was really present in every use case, both in terms of a quality gate. So oftentimes they weren't able to proceed to sort of wider rollout until they had this kind of human review. And also as a feedback mechanism, the most common thing teams are doing is putting a thumbs up or thumbs down on their app to get some feedback to iterate on the product. And then the other insight I'll just share is that there was a lot of what I'd maybe frame unknown problems. Teams that had started building, say, a chatbot on a knowledge base that they previously hadn't had any access to, and finding maybe that knowledge base hadn't been updated or it was incomplete, and as a result, the chatbot was actually quite ineffective. So just a few kind of pragmatic lessons, I'd say, and I think some of this applies to data work and machine learning generally, but I'd say focus on deep business pains. This really should be a long-term investment, and so you want to pick your bets wisely. Second is double down on Gen AI strengths. That may or may not be a chatbot, but it could be something like summarizing, structuring the unstructured, code generation or process automation. And then, I'll say a bit more about the reliability pains that I'm seeing across these teams and how people are encountering this in production. So this was a quote from someone I spoke to, and this is kind of a necessary part of this process right now, but a human reads sort of 200 examples one by one. It's grueling. And so, all of these customers I spoke to, there was some human-in-the-loop process as part of it. There's other things that I think mean that over these applications, you need essentially observability across data, systems, code, and model. And so I'll talk about what that means. Starting with data, this is one of the common issues I heard, which is effectively your garbage in. If your input data, like a knowledge base, is outdated or is poorly structured, then there's either a lot of work to do to get that into shape, or it's potentially something that's resulting in model hallucination or gaps in the modeling process. Another related issue that's come up fairly commonly, this unstructured data essentially allows you to create these embeddings, and these embeddings can drift over time depending on the nature of the unstructured data. And so teams just have very little visibility today into some of these potential problems in the data that can silently kind of degrade the model. The second issue tends to be a systems failure at scale. You have chunking, embedding, retrieval, prompts, models, a bunch of new systems as well as potential legacy systems at play. And so this tends to require you to have an understanding of the lineage across this system, an ability to diagnose where the pain points are. Third is a code issue, and I kind of call this one small tweaks, big surprises. The amount of teams that talk to me about, say, an upgrade in the version of GPT 3.5 to 4.0 that actually caused them to have to retrain their entire model because of the changes that it made to summarization. So that's one code change, but prompts could also be a code change. Underlying data pipelines undergo code changes all the time. This is a potential cause of flakiness in your AI application that you need to be able to get ahead of. And then finally, you've got the model and, commonly hallucination, but there's other ways this model might not be fit for purpose. Might not be able to read this, but amusing example from Google that suggests adding non-toxic glue to a pizza in order to keep the toppings in place. So yeah, holistically, I think it's critical for these applications to have visibility across data systems, code, and model. And then I will just end on a couple of notes about operationalizing reliability and trust, and maybe some of what we did. So one, I think it's about building these integrated teams, and actually the more data teams I spoke to, and I typically speak to data teams, they were either supplying the talent to cross-functional teams or they were building cross-functional teams themselves. And so that needs to have product, design, engineering, data science as part of it. Allow time for the research, not just development, and start from the user and actually involve the user in the process. The people that were deploying these to production most commonly were working hand in hand with their user base to get feedback as they went. And then finally, how to stay ahead. So the work may be mysterious and important. That's probably never more true than for generative AI apps. They're, as I sort of talked about, they're non-deterministic. They're very hard to understand sometimes. But there are some ways you might put reliability at the forefront for your launch. And so just a few ideas here. As I mentioned, I think proof of concepts and experiments are the fastest way to figure out if your data is actually AI ready. Don't sort of sit on the fence and wait for that. Secondly, prioritizing human-in-the-loop systems, both as a gate for quality and also with this kind of thumbs up, thumbs down feedback. Evaluate the required level of precision. Not every application needs to be 99.9% accurate. I've talked to people who are building solutions in government-regulated industries where they have to be incredibly accurate. I've talked to others who are using this for a productivity boost, and it just needs to be better than what they're doing today. So enough reliability and not too much is often how I think about it. And then I just plug implementing data and AI observability across this system. That's it for me. Thank you.
Hey, thanks. Any question? Maybe we have time for one question. No? Okay. Oh, the question.
What is the kind of latency you're seeing in the two implementations you discussed?
The troubleshooting agent?
Yes.
So it's relatively fast. That's delivering, basically delivering recommendations in under a minute, but it's something that you're comparing to, potentially engineers going and exploring hypotheses and doing a lot of this work manually. So it's probably one that doesn't need to be like sub-second latency. It's something that you can kind of have working in the background to go and explore these. But it's still pretty fast because, as I said, it kind of parallelizes these LLMs.
Okay. Thanks, Shen.
Thank you.